oxidation number. Calculate the oxidation number. So compound number 1 is PbSO4. So you have to calculate the oxidation number of Pb. How would you do that? See, now there are two ways, right? Second compound
Ma'am,
I'm
the
writing
answer
down.
will be, I think the answer will be plus 10. Because it will be -4 oxidation in the combined state will always be -2.
See, how do we do this? So it is NH4 whole twice SO4. So these are the compounds in which I would like you to calculate the oxidation state, right? So how do we do it? See, basically, we know that sulfate is a radical, right? So when sulfate is a radical, what exactly does that mean? That means that you are breaking this down into Pb plus 2 and SO4 minus 2. So I do not have to understand very important part here that when you talk about this sulfate, right? Sulfate by itself is carrying an overall of -2 charge. Are you understanding? And Pb is
Yes.
carrying a charge of +2. You understand? Pb is carrying a charge of +2. So what exactly does that mean? Just tell me. What exactly does it mean? That Pb, the charge of oxidation, the charge or the oxidation number of Pb hereby would be +2. So in this case, you do not have to know what charge the sulfur is going to carry. Because if you remember, in the previous video or in the previous class, we learned about what oxygen can hold. Oxygen always in the combined form holds a charge of -2, right? But if you are aware of the radicals, so in that case, radicals, you have SO4 -2. So -2 is the overall charge. So when you consider this PbSO4 breaking down, so you know that it is going to break down in a positive radical and it is going to break down in a negative radical. Yes or no? And hence, if I am asking you the oxidation number of Pb, it shall be +2. Now, in the same question, if somebody asks you that what is the oxidation state of sulfur, then also you separate Pb plus 2 and SO4 minus 2, right, Atu? So it becomes SO4 minus 2. So you do not need lead in that case. The Pb requirement is 0 there. You do not need Pb.
Yes.
So just from sulfate, you can calculate. How would you calculate? You will say let sulfur charge be X. Let oxygen charge be -2. So thereby for 4 oxygens, it would be -8. And the overall entity's net charge is -2. So it becomes X is going to be -2 plus 8. So X is thereby going to be +6. So do you understand that sulfur charge is going to be what? Sulfur charge is going to be +6. Are you understanding? Right. So here chromium is going to be X. Next question. In chromium, how do you calculate the charge? Let the chromium charge be X. And for one oxygen, it is going to be -2. So therefore, for 4 oxygens, it is going to be -2 times 4. And hence the overall charge is going to be -2. Did you understand? So you have X minus 8 equals to -2. And hence X is going to be -2 plus 8. That is going to be 6. So here in this question, CrO4 -2, the chromium's charge, let chromium's charge be. Let chromium's oxidation number be. Let chromium's oxidation number be X. And hence that value comes out to be +6. Did you understand my point, everybody? Tatu, did you understand? Next is we have Sb2O5.
Ab plus.
Sb2O5. Yeah. So here you have to calculate the charge of Sb. So you understand if you are given a compound, right? How do you know that whose charge you need to calculate? See, understand. By rules, you know for hydrogen, by rules, you know that fluorine will always acquire a -1 charge in the combined state. By rules, you already know that mostly in the combined state, oxygen acquires a -2 charge. By rules, you
Yes.
know that, nitrogen will always acquire -3 in all the cases where nitrogen is more electronegative. Wherever nitrogen is connected to more electronegative, then nitrogen might acquire a positive charge, right? So what I'm trying to tell you is that here Sb is something, antimony is something whose rule we have not studied to calculate the oxidation number. So we say let antimony's charge be X. So you imagine that when Sb2O5 breaks down, it gives me 2 Sb radicals and 4 oxygen ions. You understand my point?
Yes.
So what is going to happen? That Sb is going to have, let Sb's charge be X. So 2 Sb's charge be 2X. 1 oxygen is -2. So 5 oxygen is going to be -10. And hence net charge is going to be 0. So 2x is going to be 10. So x is going to be 5. Did you understand my point? So SB's charge is going to be 5. Are you understanding? Right?
Yes.
Because by rules, 1 oxygen carries -2 charge. So 5 oxygen shall carry -10 charge. Did you understand my point?
Yes.
Next is, the question is NH4 whole twice SO4. NH4 whole twice SO4. And here you have to calculate for nitrogen. So you understand that how does this radical breaks down? This radical breaks down into what? This radical breaks down into NH4 plus, because it is formed by the crisscross of two radicals, NH4 minus 2. So ammonium sulfate, what is NH4 whole twice SO4? It is ammonium sulfate, yes or no? So
Yes.
this ammonium sulfate is formed by the crisscross of ammonium and sulfate. So what is going to happen? You tell me.
If
What
it
is going
plus
to
1,
happen? Right,
the other charge will be 0.
right. So let our nitrogen's charge be, let's say, X. You
Yes.
understand? Nitrogen's charge be X. Right? And for hydrogen's charge be, what would be hydrogen's charge? Hydrogen's charge is by rules, it is +1, but there are 4 hydrogens. So +1 times 4 is going to be +1. So here it is going to be x plus 4 equals to +1. So x is going to be 1 minus 4. So x is going to be -3. Did you understand my point?
Yes.
Yes or no?
Yes.
So x is going to be -3. Got the point?
Yes.
Did you understand? So here nitrogen's charge is -3. So whenever you are able to identify a radical, you do not have to worry about the other radical, because that is totally insignificant for the first radical, right? That does not even affect it. So now next question that you have is what? You have P4. Now tell me the charge on phosphorus. S8. Tell me the charge of O2. Mg. Fe. Tell me the charge of all of these.
On NP4 it is -3. So
Yeah. Now understand. What is P4? P4 is a molecule, right? And this molecule consists of
it will be -12.
four phosphorus atoms. So you understand that when 4 phosphorus atoms are
Then in the
connected
square
to
line
each other,
each of them will be shared.
tell me.
The overall charge will be 0.
Yeah, because the electrons will stay
Ma'am,
exactly
if
in
you
the
put
center. It is a native form. So in the native form,
yes.
every element acquires a 0 charge. Now when I say S8, all the sulfur atoms are joined to each other. So when this molecule breaks and all sulfur comes out of it, what is happening? 1, 2, 3, 4, 5, 6, 7, 8. So the 2 electrons remain exactly in the center. Did you understand my point?
Yes.
The 2 electrons remain exactly in the center. You understand my point? Tell me. So when this remains exactly in the center, every sulfur carries a 0 charge. Right? Because when it comes out exactly neutral. All it is carrying with itself its own electrons. Did you understand my point? So when you have
Yes.
oxygen, it is O double bond O. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Did you understand my point, Tatu? So O and O shall break down. So O will take its own electrons and the another oxygen shall take its own electrons. So oxygen comes up, or from the molecule it comes out in the form of its own electrons. Did you understand?
Yes.
Did you understand? So Mg is neutral. Iron is also neutral. So net charge oxidation state of iron is 0. For magnesium is also 0. Now let's take an example of PO4 whole thrice -3. How do you calculate the charges? Just see. So you have to understand that let's phosphorus charge is X, right?
Yes.
Let phosphorus charge be X. In the combined form, oxygen charge is
Right.
-2. So for 4 oxygen, it would be -8. The charge of phosphorus plus the charge of all the oxygens combined together would be equals to -3. That's what we learned.
Yes.
Because if I look at from the structure also, I know this structure is like this. Do you understand my point? This is a structure.
Yes.
So from structure, also you can see the same thing. I'll explain it to you in detail. But you understand that it is going to be -3. So x minus 8 is going to be -3. X is going to be -3 plus 8. So x is going to be plus 5. Did you understand my point? Yes or no? So basically, we have the charge on phosphorus as +5. Is this part clear?
Yes.
Right? Now, similarly, if I ask you to calculate MgNO3, and here I want you to calculate the charge on nitrogen. So there are two methods for this, right? One rule you have to understand that all alkali metals acquire +1 charge. What are the alkali
Ma'am, but
metals?
this is an
Lithium.
alkaline earth metal.
Yeah. Lithium, sodium,
An
potassium,
alkaline earth.
magnesium, cesium, right? And all alkaline earth metals. So two rules I have to tell you, no? Or in the combined form. +1
Ma'am,
charge in the combined form. And all alkaline earth metals, magnesium, calcium, strontium, barium, radium, in the combined form shall always acquire a +2 charge. Did you understand? Will always acquire a +2 charge. So now here Mg is there. Mg belongs to which category? Alkaline earth metal. And the reason is very simple because magnesium carries the magnesium's atomic number is 12. So the configuration would be 282. So it is going to lose 2 electrons. You understand? And when it is going to lose 2 electrons, Mg is going to acquire a +2 charge. Mg is going to acquire a +2 charge. So when Mg is +2, NO3, let NO3's charge be, let nitrogen's charge be X. So it is going to be what? Plus X minus 2. What is -2? -2 times 3 because there are 3 oxygen. Net charge of the entire compound is 0. Because when I write down MgNO3, I do not write down any charge. Do you understand? So it is 2 plus X minus 6 equals to 0. So X minus 6 plus 2 equals to 0. So X minus 4 is going to be 0. So X is going to be 4. So nitrogen's charge here would be what? Oh, sorry. It is going to be MgNO3 whole twice. I'm so sorry. It is going to be MgNO3 whole twice. So when it is MgNO3 whole twice complex, how do you get to the charge values? Just see. So you say, let nitrogen's charge be X. So if I open it up, if I open up the radical, how do you go about it? Just see. You can write this down as MgN2O6. Did you understand the point? You can write this down as MgN2O6. So magnesium's charge is +2. Nitrogen's charge is X. So for 2 atoms, it shall be 2X. And for oxygen, it would be -12 equals to 0. So 2X minus 10 is going to be 0. So you will have 2X equals to 10 and X is going to be 5. Why am I saying that? That because the charge of one nitrogen is assumed to be X. But there are how many nitrogens? There are 2 nitrogens. Are you understanding my point? Yes or no? Are you understanding?
yes.
Right? The two?
Yes. I understood.
Yeah. Next we have NaCO3, Na2CO3. That's the complex. Now in Na2CO3, you have to calculate the charge on carbon. The first method is you should know that sodium belongs to alkali metal. Alkali metals, if I see Na's atomic number is 11, so its configuration is going to be 281. Yes or no? When its configuration is going to be 281, what exactly does that mean? You tell me. What exactly does that mean? When sodium's configuration is 281, it is going to lose 1. So Na acquires a +1 charge. So here you understand, we have already given you the rule that whenever we have got an alkali metal, the charge of that alkali metal is going to be +1. You understand? The charge of the alkali metal is going to be +1. So when sodium's charge is +1, there are 2 sodium atoms. So I would write down +2. Why am I going to write down +2? I would say let sodium charge for 1 sodium is 1. So times 2. Let carbon's charge be x. And oxygen charge is -2 times 3. So it shall be -6 equals to 0. So it is going to be x minus 6 plus 2 is going to be 0. So x minus 4 is going to be 0. So x here is going to be 4. So carbon's charge here is going to be +4. Did you understand the point? Carbon's charge here is going to be +4. Any doubts in this? Right? So this is Na2CO3. Concept समझ में आया? Right? Is the concept clear? Next complex that we write down is KMNO4. Calculate the charge on Mn. So you say potassium K belongs to which category? Alkali metal. So it is +1. Let manganese charge be X. For oxygen, what would you say? Or for oxygen, so you say there are 4 oxygen and every oxygen in the combined state shall carry a -2 charge. Net charge would be 0. Yes or no? So here it is going to be 1 plus X minus 8 is going to be 0. So X minus 7 is going to be 0. So X is going to be +7. So X is going to be +7. Similarly, if I talk about K2, Cr2, O7, what would you say? If we talk about K2, Cr27. Let potassium's charge, we know already that potassium carry a +1 charge. So for 2 potassiums, it is going to be +2.
It will be -12. So Kr2 will be, so Kr will be +6.
Very good. Chromium's charge is X. So for 2 chromium, 2X. Oxygen is going to be -2 times 7. So -2. But there are 7 such oxygen atoms. Overall, it is neutral. So 2 plus 2x minus 14 is going to be 0. So 2x minus 12 is going to be 0. So x is going to be 6. Did you understand my point? So this is how we calculate. Next is we have MnO2. Mn is going to be plus. Let Mn's charge be x. For 1 oxygen, the charge is -2. So for 2 oxygen, it is going to be +2 times -2. And the net charge is going to be 0. So x minus 4 is going to be 0. So x is going to be +4. Did you understand my point? Did you understand my point? Yes or no? Yes or no?
Understood.
Now, similarly, we have KClO3. This is potassium chlorate. This is potassium chlorate. So potassium's charge is 1. So for 1 chlorine, it shall be x. For 1 oxygen, it is going to be 3 times -2 is going to be 0. So x plus 1 minus 6 is going to be 0. So x minus 5 is going to be 0. The charge of x is going to be +5. Did you understand my point?
Yes.
Yes or no?
Yes.
The chlorine's charge here would be. So basically, I do not know the rule of chlorine. Why so? Because I know that chlorine is less electronegative than oxygen. Had it been an opposite case, let's suppose if I say that chlorine in a compound becomes more electronegative. Let's, for example, if I say that I have KCl. Now in KCl, I already know that potassium is a metal and chlorine is a non-metal. Definitely chlorine will be more electronegative. You understand? Definitely chlorine shall be more electronegative. And if chlorine is more electronegative, what exactly does that mean? That it is going to show its own valency. So whosoever is more electronegative, first see that. Whosoever is more electronegative. You understand? Whosoever is more electronegative carries a -1 charge. Whosoever is more electronegative carries a -1 charge. Did you understand my point?
Yes.
Got the point? carries a -1 charge. So K is going to be +1 and Cl is going to be -1. Yes or no? So in that case, -1 charge, or I would say it would show its own valency. Here we are talking about chlorine. So chlorine's atomic number is 17. So its configuration is 2H7. It gains 1 electron. So chlorine acquires a -1 charge. Did you understand my point? Yes or no? So chlorine acquires a -1 charge. Like that. Yes or no?
Yes, I understand.
Next, what do we have? Next, what do we have? We have another compound. Now, let's suppose if I say NH2OH. This is hydroxyl. This is hydroxyl. This is what? This is hydroxylamine. Hydroxylamine. Okay, this is hydroxylamine. So when we are talking about nitrogen, let nitrogen's charge be X. Why I have to assume for nitrogen? Because I know that order of electronegativity is what? Fluorine, oxygen, nitrogen, chlorine, then bromine, then iodine. You understand? This is the order.
Ma'am, will be
So hydrogen in the combined state, and hydrogen is what? Hydrogen is least electronegative. So hydrogen is going to be +1. So for 2, it shall be +2. For 1 oxygen, it is going to be -2. For 1 hydrogen, it is going to be
busy.
+1. Overall charge is 0. So X is here going to be -1. So here nitrogen is going to
Yes.
show a charge of -1. Did you understand my point?
Yes.
Right? Next compound you have. Next question we have NH2. NH2. This compound is hydrazine. And now when I say hydrazine, you have to learn the formulas. Okay. Because the question, it is not going to be tough. All it is going to be, they're going to give you the names. So one question they can easily frame that what is the oxidation state of nitrogen in hydrazine? Now the question comes up that when they're asking you the oxidation state in hydrazine, you should know the formula. So it's very important that you learn the formulas for a particular compound, right? So now what do? You have 2 nitrogens. What would you do?
Will be
You say nitrogen. Let one nitrogen's charge be. Let one nitrogen's oxidation state be
it's -2.
Bx, right? So for 2 nitrogen X, for 1 hydrogen it is going to be +1. So for 4 it is going to be +4. Overall it's going to be 0. So 2x equals to -4. So x is equals to -4/2. And that would mean -2. That means x is going to be -2. Got the point? Got the
Yes.
point or not?
I got it.
Right? Next is, so why am I giving you nitrogen example? I want to tell you certain things. When I say N2, what is the charge of nitrogen? 0. Because N2 means it is in the native
It does
state.
not, it cases where it doesn't obey octet rule, like NO2.
Sorry?
Like NO2, I
It
don't
does
think it
not.
obeys octet rule.
NO2. No, it is an odd molecule substance and its octet is not complete. But since it is a neutral compound, I will show you compounds how it exists. Just see. So we have got N2, right? Nitrogen's charge would be what? 0. If you want to prove it also, you say let nitrogen's charge is X. For 2 nitrogens, it shall be 2x. Overall charge is 0. So X would also be 0. You understand? And also you can see that nitrogen would be connected to itself. So whenever nitrogen comes out of this bond, it is going to take away these electrons. You understand my point? So when you're talking about nitrogen, let nitrogen be X. And hydrogen would be +1. So for 3 hydrogens, it is going to be +3. Overall charge is going to be 0. So X is going to be -3. So here in ammonia, nitrogen carries a charge of -3. Next question, if I give you N2O3, next complex I'll give you N2O4. So basically NO2 does not follows octet rule. So it dimerizes itself. It dimerizes itself. You understand? It dimerizes itself. So N2O3, let nitrogen's charge be X. So for 2 nitrogen, it shall be 2x. For one oxygen, it is going to be minus 2. So for 3 oxygen, it shall be minus 6. Net charge is going to be 0. So 2x is going to be 6. So x is going to be 3. You understand the point? X is going to be 3. So one nitrogen, it is going to be x. So for 2 nitrogen, it is going to be 2x. For one oxygen, it is going to be minus 2. So for 4 oxygen, it is going to be minus 8 equals to 0. So 2x equals to 8. X equals to 4 plus 4. Did you understand? For one nitrogen, another compound, I would take up nitrogen N2O5. So one nitrogen is x. So two nitrogens would be 2x because I do not know the charge on nitrogen. So for one oxygen, it is going to be minus 2. So for 5 oxygen, it is going to be minus 10 equals to 0. So 2x equals to 10. So x here would be equals to 5. Did you understand my point? So this is going to be N2O5. You understand?
Yes.
Right. Next, we have HNO2. What is HNO2? HNO2 is nitrous acid. HNO2 is nitrous acid. So let nitrogen's charge be X. For one hydrogen, according to rules, it is plus 1. And for one oxygen, it is going to be minus 2. So for two oxygen, it is going to be minus 4 equals to 0. So X minus 3 is equals to 0. So for X, it is going to be plus 3. For X, it is going to be plus 3. In nitrous acid, nitrogen requires a charge of plus 3. You understand?
Yes.
All right, next question. Now, if I give you CrO5, if I give you CrO5 configuration, you have a look. Let chromium charge be X. Let chromium charge be X. And for one oxygen, what we calculate is, for one oxygen, what we calculate is that it is minus 2 by rules. Because chromium carries a positive charge. Chromium carries a metallic charge.
Yes.
So minus 2 times 5 would be 0. So X minus 10 would be 0. So X here would be equals to what? Plus 10. Did you understand? So X would be here equals to plus 10. Got my point? So when chromium's charge here is going to be plus 10, what does that mean? That is not possible. Why? Because we have to remember one very important thing, that chromium's charge, chromium's positive charge is going to be
You only
plus
go up to plus 6.
maximum. Yes. Now it is not possible. That means this method of calculating the oxidation state of chromium is wrong. Or I would say this method does not suit to CrO5. So what are we supposed to do? We are supposed to adhere to the structure method. We are going to draw the structure. And just remember, CrO5 has this butterfly structure. Okay? CrO5 has this butterfly structure. Now, here what is happening in this butterfly structure, right? What is happening in this butterfly structure? You see two oxygens connected to itself. This oxygen 1 and 2. The two black oxygens and the two red oxygens. Do you imagine that if you break this bond between them, the two electrons, the dot and the cross electrons, the black dot and the black cross, and similarly, we are talking about the black oxygen and the dot oxygen and the cross oxygen. So if I break this bond, do you realize that none of the oxygen is biased? One oxygen takes away its own oxygen, another takes its own oxygen. This takes its own
Maybe
oxygen.
0.
Yeah. So from this particular bond, no contribution of charge to any of the oxygen is taking place. No contribution of any charge. Now you understand. But what happens when chromium oxygen bond breaks? This bond breaks. Now chromium is less electronegative. So when this bond breaks, both the electrons, the dot and the cross, right? They are taken away by oxygen. So when this oxygen comes out of the molecule, it is carrying by itself a -1 charge because it is carrying that extra electron from chromium. You understand? Similarly, when this oxygen, this one oxygen, purple oxygen comes out, it is not carrying any charge. It is bringing with itself, right? Just see, it is bringing, this oxygen is carrying with itself only one electron from here. And one electron from where? One electron, its own electron and cross electron. So basically it has its 1, 2, 3, 4, 5 and 6. Right. So the individual 4 electrons are intact. One electron it is bringing with itself its own electron, but it is carrying with itself an extra electron of chromium. So this oxygen comes out with -1. So did we learn by rules that when oxygen is connected to another oxygen by a single bond, what do we call it as? We call it as a peroxide. We call it as a peroxide linkage. Did you understand? Did you understand? And when you call it as a peroxide linkage, both the oxygen shall carry a -1 charge because this single bond, this red single bond here, is not making any contribution. Do you understand? Yes
Yes,
or
it's
no?
not fulfilled.
Yeah. So all the
There,
4
it'll
oxygens that
just be
come out.
28.
So 4 oxygen which are in the peroxide linkage, they are carrying a charge of -1. But when we were doing this method, we assumed all the bonded atoms to carry a -2 charge. Yes or no? And hence that's where the difference lies. Now, similarly, you see here, when we are talking about the oxygen part, what is happening? The 2 electrons are here. Another electron is there. So this bond kinds of breaks. Now, oxygen being more electronegative takes away the electrons from chromium. Did you understand? So chromium carries by what charge? It loses 1 electron to this oxygen, 1 electron to this oxygen, 1 to this, 1 to this. So it carries a charge of +6. Chromium carries a charge of +6. Did you understand my point?
Yes.
Yes or no?
Yes.
So then chromium is in its correct oxidation state. So that's the compound. Got my point?
Mhm.
Now let's calculate for HCN. Now you have to calculate for C. Now the question is, we have not learned any rule for nitrogen in the combined state. Yes or no? We have not learned any rule for nitrogen in the combined state. How do we do this? What do we say? So we say that, H, for example, I know that H whenever is connected to non-metals.
It'll
H
be
whenever is connected to
-1 and
non-metals.
carbon minus +1 5, which is suitable for
Sorry?
which will be suitable for nitrogen.
No, I'll tell you. I'm telling you.
No,
H is connected to
hydrogen and carbon will be -4.
always be +1. No. Hydrogen shall always be connected to non-metals. Whenever hydrogen is connected to any non-metal, consider it to be a +1 charge. And nitrogen, you know the order. Phone call, fluorine, oxygen, nitrogen, chlorine, and then bromine, and then iodine. So you know here that nitrogen is less electronegative. Nitrogen is more electronegative because carbon does not lie in any of these positions. Did you understand my point? So when carbon
Yes.
does not lie in this series, when carbon does not lie in this series, then what happens? That means it is assumed that carbon is less electronegative than nitrogen. It is calculated also. Carbon's electronegativity is 2.1. Nitrogen's electronegativity is approximately 3.04. You
So all
understand?
electrons go with.
Yeah. So now whosoever is most electronegative will always in the combined state show its valency, the natural valency. So nitrogen's atomic number is 7. Configuration is 2,5. You know that it is going to gain 3 electrons. So here nitrogen shall always be -3. So you do not have to learn the rule. Look at the structure, look at the structure and see if any electronegative element is present. Whosoever is the maximum electronegative element will always acquire its own charge. You understand? So now when I say here that carbon is, I do not know what is the charge. So let carbon's charge be X. Hydrogen's charge is going to be +1. Nitrogen is going to be -3 and overall 0. So x minus 2 is going to be 0. So x is going to be +2. Did you understand the point?
Ma'am, is this even applicable for oxygen, or oxygen will always be -2?
Oxygen can be -2, can be -1. Now, when I give you this example of CrO5, you have to remember this example of CrO5, that whenever next time chromium anhydride comes up, this is CrO5, right? This is chromium pentoxide. So chromium pentoxide, when you learn, you should know that next time when this structure comes, you should know, you should remember these structures. So why am I doing these? Because when next time these structures come, you do not make the mistake, right?
Yes.
If in the question they ask you that, what is the charge of nitrogen in HCN, what would you say? What would you say? Tell me.
Sir?
Did you understand?
Maybe +1.
Right. Now calculate. Next is Fe3O4. Calculate the oxidation number of iron in Fe3O4. What would you say? You will say let iron's charge be X. So for 3 iron, it would be 3X. For 1 oxygen, it is going to be
Ma'am, we have
-2.
to draw
So
the
for
diagram.
4 oxygen, it is going to be -2.
We have to
That's
draw the diagram.
sorry.
Because it's fractional oxidation state, we have to draw the diagram.
Right. Now understand. So that is wrong. I would not say this is wrong. Oh, sorry. I would not say this is wrong. I would say this is
It's not, it's an average.
average. This is average oxidation state. You understand? Now you understand. How do I say Fe3O4? Fe3O4 is a mixed oxide. Because in the previous and younger classes, you must have learned that iron exists in 2 charges, Fe2 and Fe+3. So when we talk about Fe3O4, how would you say? You would say that FeO and Fe2O3. You understand? So it is FeO and Fe2O3. Got my point? So if you break this down and you acquire +2 and -2, you understand? So basically, Fe3O4 is a mixture of FeO plus Fe2O3. Did you understand the point? And here it is going to be Fe+3 and O -2. So you will say that Fe2O3, when it breaks down, it gives off 2 Fe+3 and 1 Fe+2. You understand? So the actual charges, how do you know actual charges on iron? You say that Fe3O4 is a mixture of FeO and Fe2O3. So 1 iron carries a Fe+2 charge and 2 iron carries a +3 charge. So the correct option would be 2, 3, 3. Do you understand? So 1 iron carries a +2 charge, 1 iron carries a 2 iron atoms carry a +3 charge. Yes or no? Yes or no?
Yes. Yes.
Right? Next complex is uh did I do CaOCl2 with it? No, next complex is Na2 S2O3. Okay? Na2 S2O3. Now, how do you exactly do this, right? Calculate. So I would say let sodium charge be 1, because by rules Na is an alkali metal, so Na is +1. So for 2 atoms, it would be Na +1
And
times
it'll be
2. For 1 sulfur, it is going to be X. So for 2
-2.
sulfur, no. Right. And then -6 is going to be 0. So it is going to be what? It is going to be what? So 2x
-2.
-4 is going to be 0. So x is going to be 4. So here this 2x is going to be 4. So x is going to be 2. Now this what we are calculating. And now see, understand. There are 2 sulfur. There
Yeah,
are 2
yes.
sulfur, right? So when there are 2 sulfur atoms, and if I say that the average charge is +2, the question is what is the exact charge? What is the exact charge on S2O3? Na2S2O3. Now I have to draw the structure. So first you understand that how does Na2S2O3 breaks down? Na2S2O3 breaks down into S plus. and S2O3 minus 2. This is thiosulfate. This is thiosulfite. Did you understand?
Yes.
Now I have to draw the structure. Now structure in reality the structure exists like this. The structure exists like this. S S O coordinate bond O coordinate bond O. You understand? The structure in reality is like this. And this O negative is connected to Na plus and this S negative is connected to Na plus. It is S2O3. It is like this. This is the structure. Did you understand?
Yes.
So one sulfur, how much charge it is going to carry? 2 electrons will be lost by oxygen. 2 electrons, the dot ones will be taken away by this oxygen. And 1 electron will be lost by this oxygen. So basically this sulfur carries a +5 charge. Now with this sulfur, the blue sulfur, the blue bond is there. Yes or no? The blue bond is there. And the 2 electrons are there. So where will this electron shift? You tell me. Tell me. So this sulfur is not contributing, right? This sulfur is not contributing to this sulfur because both the electrons are same. So here it is exactly going to be in the center. Yes or no?
Yes.
Did you understand?
Yes, I understand.
So this sodium has donated one of its electron to sulfur. So this sulfur carries a -1 charge. Because sodium is 281, atomic number 11. So configuration is 281, so it is going to donate 1 electron. You understand? So Na when it donates 1 electron, what is going to happen? Just tell me. Just tell me. So it is going to be S double bond O, double bond O, O negative, Na positive, and this is going to be S negative. Do you understand my point? Right?
Yes.
So you have to understand the actual charges would be in S2O3. The actual charges would be what? +5 on one sulfur and -1 on another sulfur. So the 2 sulfur carry this kind of charge. Yes or no? Right? Next structure is what do we have? We have NOCl. This is also called as Tilden's reagent. Tilden's reagent.
Yeah.
You understand? So when it breaks down, it forms NO plus 1 and Cl minus 1. And NO plus is basically nitrosyl ion, or I would say nitrosonium ion. Nitrosonium ion. Do you understand? So when it is nitrosyl ion or it is nitrosonium ion, that is the concept.
Yeah.
Yes or no? And here you have to calculate the charge on nitrogen. Now there are 2 ways. You break down the radical because you know the charge on chloride. And when it breaks down, you get NO plus 1. So when you get NO plus 1, so overall radical is carrying NO plus 1, nitrogen's charge is X. So when nitrogen's charge is X, oxygen charge is -2. Overall charge is +1. So nitrogen here would be +3 because X would be 1 plus 2. 2 goes here. So nitrogen's charge here would be +3. Got the point? That's how it is going to be. So in NOCl, nitrosyl chloride, that's how the structure is going to be. Okay? Next charge, what we have is CH3 whole twice SO. CH3 whole twice SO. Now look at the structure. Look at the structure. This you have to do it with the structure. So it goes like this. It goes like this. Okay? So you have to calculate the charge on sulfur. Now just tell me, carbon is more electronegative or sulfur? Carbon is
Sulfur.
more electronegative or sulfur?
Sulfur.
Carbon. So this electron goes towards sulfur. So sulfur takes its own cross electron, and also sulfur takes its own dot electron.
Yes.
Another sulfur takes its own dot electron and cross electron. So when this bond breaks, this bond breaks and this bond breaks. So sulfur is acquiring a -1 charge from here and -1 from here. So overall it requires a -2 charge. Now oxygen does what? Oxygen, when this bond breaks, takes away its own 2 electrons and it's the cross electrons. So because of oxygen, it requires a +2 charge. So overall charge on sulfur becomes what? What is the overall charge on sulfur? That is 0. You understand? That is the overall charge on sulfur. Got the point?
Yes.
That is the overall charge on sulfur. Next is N3H. That is called as hydrazoic acid. Next is hydrazoic acid. 1 second. There are 3 nitrogen atoms, right? So you
Yes.
say let the charge of, or let the oxidation state of nitrogen be X. Let the charge of nitrogen be X. So when nitrogen charge is X, so for 3 nitrogen, it is going to be 3X. Yes or no? For 3 nitrogen, it is going to be 3X. And hydrogen is a non-metal, but you know that hydrogen is connected to a higher non-metal, highly electronegative non-metal. So definitely hydrogen, when it is connected to a non-metal, it acquires a +1 charge. So overall +1 is going to be 0. So 3x is going to be -1. X is going to be -1 over 3. So that is going to be the answer. Yes or no?
Yes.
Is this point clear?
Yes. Yes.
Yes or no? So x here is going to be -1. Right?
Yes.
Next is FeCO whole 5. This is iron or ferrous carbonyl. You have to calculate the charge on iron. Here the CO is carbon monoxide. Right? So let iron charge be X, and carbon monoxide, you have to remember, it is a neutral complex. Is a neutral compound. So X plus 0 into 5 is going to be 0. So X plus 0 is going to be 0. X is going to be 0. So that means any metal carbonyl, if I say NiCO whole 4, then on the charge of nickel would be 0.
And I will be.
You understand? Yeah, because it's carbon monoxide. This CO is nothing but carbon monoxide. So when it is carbon monoxide, so it is going to be X plus 4 times 0 shall be 0. So X will be again 0. Yes or no? X will be again 0. Did you understand the point? Right? Any metal carbonate. Let's suppose if I say Mn2CO whole 5, CO whole 10. It doesn't matter, you straight away say that manganese shall carry a 0 charge. Because even if you calculate by the method, you say let 1 manganese carries X charge. So 2 manganese shall carry 2X charge. 1 carbonyl carries 0 charge. So 10 carbonyl also carries 0 charge. Equals to 0. So 2x plus 10 is going to be 0. So 2x is going to be minus 10. So x is going to be 2x is going to be 0. So x is going to be 0. That means manganese in the metal carbonate carries 0 charge. Got the point?
Yes.
Now there is this complex which is called as Ki3. Now, how do you break this down? Remember this. This is a triiodide ion. It is going to break down like this. Potassium shall always carry +1, right? Because potassium is an alkali metal compound. So when potassium carries a +1 charge, so it is going to be what? K +1 and I3 -1. Yes or no? So how do you
Yes.
break this down? How do you break this down? Tell me. It is a triiodide ion, right? So you say let one iodine charge be X. So for 3 iodine, it shall be 3X. For 3 iodine, it shall be 3X. And hence it is going to be -1. So X here is going to be -1 by 3. Yes or no? So here it is going to be -1 by
Yes.
3. But again, it is going to be an average charge, right? And we will discuss the structure of I3 -1 in the next class. So you will understand that how every individual iodine is carrying what is the individual and actual charges of every iodine, right? Next would be what? KO2. Now this is potassium superoxide. This is potassium. This is potassium superoxide. Okay. Right. So potassium carries a +1 charge. And O2 -1 is a superoxide radical. So O2 -1 is a superoxide radical. You understand? So let one oxygen be X. So for 2 oxygen shall be 2X is going to be -1. So 2X is -1. X is going to be -1 by 2. Did you understand my point?
Yes.
So one oxygen is carrying a -2 charge. -1/2 charge. The superoxide radical you have to remember, right? Because potassium will always carry +1 no matter what. Is this part clear? Next complex that we
Yes.
have is NOClO4. It is nitrosodium perchlorate. How do you break this down? You should know that NO is a +1 radical. We just studied today. It is nitrosonium. And they're asking you to calculate chlorate. You separate the radicals and individually deal with the radicals. So ClO4 -1 is there. ClO4 -1 is there. You understand? So let one chlorine charge be X. So for 4 oxygen, it is going to be -8. Overall is going to be -1. So chlorine here carries a +7 charge because -1 + 8 would be a +7 charge. Yes or no? Any doubts in this?
No.
Right? So this is how we should know how to calculate the oxidation states of several elements. Now, let's suppose I want you to calculate the oxidation state of several acids, right? So we should know how to calculate the oxidation states of several acids. Similarly, if I tell you C3O2, this is carbon suboxide. Now, carbon suboxide, let carbon charge be X. So for 3 carbon, it shall be 3X. So for 1 oxygen is -2. So for 2 oxygen shall be -4 equals to 0. So 3X is going to be 4. So X is going to be 4 by 3. Now, this is the average oxidation state. This is the average oxidation state. Yes or no? So when you have C, double bond C, double bond C, double bond O, double bond O, what do you do? This is the structure. But average oxidation state does not always represent the actual charges. Did you understand? Right.
Yes.
So here, what is the charge on carbon 0? This carbon loses its 2 electrons to oxygen, this carbon, the blue one. So it requires a +2 charge. And this black carbon loses 2 of its electrons to another carbon, so it requires a +2 charge. You understand my point? Yes or no? So basically, the original charges on each carbon would be 2, 0, 2. Yes or no? But always remember that whenever whenever hydrogen is connected to sodium, calcium, magnesium, or any alkali metal, or any alkaline earth metal, or any alkaline earth metal, right? It will means H will always acquire. H will always acquire -1 charge. That means if I say that NaH, sodium hydride, so you break it down, H will always be -1. Why so? Because sodium is a metal. So metal will always lose electrons, and hydrogen in the presence of sodium will have to forcibly gain the electron. So you say that hydrogen has 1 electron. Sodium is very, very adamant that it is going to lose 1, no matter what happens. So that 1 extra electron it is going to lose. You understand? So Na will lose 1. So Na is going to have what? H. So Na loses and becomes Na plus 1. H shall gain, H shall become -2. Did you understand?
Yes.
Got the point? Right.
Yes.
So when I say CaH2, right, what does that mean? That calcium is Ca plus 2 and H is -1. +2. Right.
Yes.
So Ca plus 2 and H -1. Got my point? So it doesn't matter H
Yes.
connected to, so you can learn a rule. H whenever connected to a non-metal, connected in the combined form shall be
Will be
H plus
+1
1. And H whenever connected to a metal shall always be H -1.
because
Yes or no?
metal tend to be on the left side of the periodic table, metal will be on the right.
Right. You can assume that. Yes. Right. Right.
Right. Yes.
So we'll be